This is Dallas James with the Royal Levitical Priesthood Ministry, and today I want to walk you through something important. We have just completed a major upgrade to the SHIELD protocol, the statistical framework that powers the Life Force Experiment workstation. We're moving from SHIELD 10.3 to SHIELD 11.0. Now, I don't use the word major lightly. A point release, like going from 10.3 to 10.4, that's a bug fix. That's a tune-up. What we've done here is replace the engine. The entire mathematical foundation that computes your sigma values, your Bayesian posteriors, your non-random test scores, all of it has been rebuilt from the ground up. And the reason we did it is because we found a fundamental flaw. Let me explain what was wrong with the old system, because understanding the flaw is the key to understanding why this upgrade matters. In SHIELD 10.3, when you ran the non-random test, that's the test that compares your prayer-guided draw against 100 random control draws. The scoring function was measuring the wrong thing. It was counting how many thematic markers appeared in the drawn verses. How many times did identity show up? How many times did priesthood show up? How much general thematic density was present? But here's the problem. It was not measuring whether those themes had anything to do with your question. Think of it this way. Imagine you walk into a library and you ask for books about covenant faithfulness. And the librarian counts all the books on the shelf and says, "We have 300 books." That's very impressive. But none of those books are about covenant faithfulness. They're about agriculture and astronomy and Greek philosophy. The count was high, but the relevance was 0. That's what the old scoring function was doing. A draw that had lots of general thematic activity would score, well, even if none of it addressed the question you asked before the draw. And that meant the p-value, the percentile rank, the whole comparison between guided and random, it was answering a different question than the one you needed answered. So what do? We built a tri-channel Content Relevance Scorer. Instead of one channel that counts markers, we now have 3 independent channels working together. Channel 1 is keyword overlap. This is the simplest layer. We take the words from your question, strip out the stop words, the and of, to all the noise, and check how many of those meaningful keywords appear in each verse. Direct lexical matching. Channel 2 is thematic alignment. This is deeper. We map your question into thematic categories using the same theme lexicon the workstation already has, categories like covenant faithfulness, priesthood, identity, authority, transformation. Then we map each verse into the same categories, and we measure the overlap. This catches the cases where the verse is talking about the same concept as your question, but using completely different vocabulary. Channel 3 is marker density. This is the original signal from 10.3, but it's been demoted from 100% of the score to 15%. It still matters. If a verse carries rare statistical markers, that's noteworthy. But it's a supporting signal now, not the whole picture. The weighting is 60% keyword overlap, 25% thematic alignment, 15% marker density. And the result is a 0 to 1 score for every single verse. A content relevance score that tells you exactly how well that specific verse addresses your specific question. The second major upgrade is the mathematical precision. In 10.3, every time the system converted a p-value to a sigma score, it used an approximation from the 1960s, the Abramovitz and Stegen formula. That formula was good to about 4 decimal places. For a single calculation, for decimal places is fine. But in the SHIELD protocol, 1 sigma feeds into a Fisher statistic, which feeds into a chi-squared test, which feeds into the GDI anomaly detector. Rounding errors accumulate. SHIELD 11 uses Acklam's algorithm, which is accurate to 16 significant digits. That's the limit of what a computer can represent. Every sigma value you see in the workstation, on the NRI cards, in the GDI, in the notable finds panel, is now computed to machine precision. Here's something that matters directly to the way we conduct LFE draws. A typical draw is 5 to 12 verses. At those sample sizes, raw marker rates are volatile. If you draw 5 verses and 4 of them carry an identity marker, that's an 80% rate. But the corpus baseline for identity is about 3%. Is that 80% real, or is it just the noise of a tiny sample? In 10.3, the system reported the raw 80% with no adjustment. In 11, we apply what's called beta-binomial shrinkage. We start with a prior expectation based on the corpus baseline and a concentration parameter equivalent to 10 virtual observations. Then we update that prior with what we actually observed. The result is a posterior mean that gets pulled back toward the baseline. Not all the way, but enough to account for the uncertainty of a small sample. And critically, we now compute a 95% credible interval. That interval tells you, given what we observed, the true rate is probably somewhere between here and here. We only flag a signal when the lower bound of that interval exceeds the baseline. That's honest statistics. The preregistration lock has been rebuilt from scratch. In 10.3, locking your criteria disabled the text box and changed the icon from an open lock to a closed lock. But under the hood, the criteria text was sitting in a regular JavaScript variable that could be changed at any time. It was cosmetic security. In 11, when you lock your criteria, the system computes a SHA-256 cryptographic hash of the text. That hash is stored in a frozen, immutable object that cannot be modified in memory. And every time you run analysis, the system rehashes the current criteria and checks it against the locked hash. If anything has changed, even a single space, the system detects it and logs a warning. This makes p-hacking, the practice of adjusting your hypothesis after seeing the data, detectable. One more thing I want to mention. Shield 11.0 doesn't just upgrade what we have. It lays the groundwork for what's coming. We've built architecture stubs for 6 future phases. Hyperbolic embeddings that will map the biblical corpus into a curved geometric space where hierarchical relationships are preserved. Mahalanobis distance for correlation-aware anomaly detection. Canonical correlation analysis for multi-channel cross-correlation. Graph-based community detection for the discovery mode. And Wasserstein distance for tracking how the meaning of concepts transforms across the corpus. These are named functions in the code right now, waiting for the pre-computed data they need. When that data pipeline is ready, the integration is a data drop, not a rewrite. The architecture is in place. So that's Shield 11. The engine has been replaced. The fundamental flaw has been corrected. The mathematics are now precision grade. Small samples are handled honestly. And the pre-registration lock has real teeth. If you've been following the life force experiment, this changes how you should interpret your results. Not because the old results were wrong. The corpus data and the baselines are identical, but because the lens you're looking through is now sharper, more honest, and aimed at the right target. This is Dallas James. The mathematics speaks, and now it speaks with precision.